So my takeaways on image upscaling in gaming. So my arrow key not working. What is the problem? So graphics in games nowadays are getting really, really demanding. People often use high resolutions like 4K, 1440p, etc. And games now use complex textures and advanced technologies such as ray tracing, which has huge hits on performance. And people like their games to feel smooth, so they want higher frame rates. So what are the solutions to this? Well, the first solution is upgrading your hardware. And based on the prices, this isn't always an option. It can get quite expensive very quickly to actually upgrade your hardware to the point where you can run games well nowadays. The second option is lowering your graphics settings, which, while that will help your performance, in some games it can look really bad, and people just like to have good graphics. So it's not always the greatest option. Then the third option is image upscaling. So what is image upscaling? Well, essentially uses some advanced reconstruction algorithm or AI to essentially take a lower resolution image and upscale it to a higher resolution image. And in terms of gaming, this would essentially work by taking your, if your native resolution is, say, 1080p, then based on whatever quality you set for the image upscaling, there might be like quality mode, performance mode, and the more performance you go, the lower the starting resolution is going to be. So if I pick balance, it might start at like 720p, and then it would essentially take that 720p image and upscale it to my native resolution, which would be 1080p. And why this works? Well, when you're rendering a game at a lower resolution, the GPU has to render less pixels, which can essentially just allow you to get higher frames. And the image upscaling still produces an image of a similar quality to that original image. And the main examples of this are NVIDIA's DLSS, AMD's FSR, and Intel's XeSS. So let's jump into those. So NVIDIA DLSS, or Deep Learning Supersampling. So it uses NVIDIA's AI cores in their graphics cards, their RTX graphics cards, called tensor cores. And that means that it's only accessible, this technology is only accessible on an RTX graphics card. And the upscaling uses temporal data to more accurately upscale, which means it essentially uses past frames as well to try and generate a more accurate image. And the way the model is trained to do this upscaling, so it uses their supercomputers and uses convolutional autoencoders, where those are fed millions of low-res, high-res image pairs, and essentially teach itself how to upscale by essentially trying to upscale the low-res image to the high-res image and comparing its result to the actual high-res image and trying to see like the error and adjust its internal parameters. And it'll repeat this many, many, many times until it's accurately upscaling it. And then that is the one that's used on DLSS 3 and below. DLSS 4 uses a transformer model, which allows for more precise adjusting of the parameters. It can adjust that more precisely and generate better quality images. So yeah, and then we'll go on to AMD's FSR, or Fidelity FX Super Resolution. So FSR versions 1 to 3 is a version that doesn't use AI, so it works on all graphics cards really, well, at least most, and it uses spatial and temporal upscaling. So once again, it just uses the current frame and some previous frames to try and upscale it as best as it can. And recently, AMD's also released FSR4, which actually uses AI upscaling, but it's limited to the RX 9000 series GPUs, so it's not very commonly used because of that. And then we get Intel's XeSS, or XE supersampling, which has two modes, an AI mode and a fallback mode. And the AI mode is only used on Intel GPUs, and the fallback mode, which will just do spatial and temporal scaling, will work on non-Intel GPUs, but obviously won't work as well. So then frame generation is something that isn't necessarily image upscaling, but it's kind of, at least in newer versions of all those features, they each have their own versions of frame generation that they've added, and it's kind of bundled into the same terminology. So I'll speak about it quickly. So frame generation works by analyzing details of the frame, like motion vectors and optical flow, and then essentially making a prediction on what the next frame would be, like a middle frame. And all NVIDIA, AMD, and Intel each have their own versions. So as you can see in this picture, it would get like this frame and some details about it, like the motion vectors and optical flow, and would essentially be able to predict like a frame 1.5 that's as close to what it can imagine frame 1.5 is. And it could still have some errors, as obviously it's not perfect, but yeah. And essentially just increases your FPS through generating synthetic frames. And then I've got a bit of a screenshot here for performance. So you can see on the left here with DLSS off and ray tracing on, all of these have ray tracing on. So DLSS off, this game was getting 21 FPS at this specific spot. And as soon as you swap to DLSS 2, which uses super resolution, then it's now getting triple the FPS, which is an insane jump, because this is 21 is near unplayable, and 63 is fine. And then you go to DLSS 3 that adds frame generation, and you get even more. And then you go to DLSS 3.5, which adds something called ray reconstruction, which is essentially just like an AI noise reducer and just handles ray tracing more efficiently. And that now gets 108 FPS, which from going from 21 to 108 is a huge jump. So yeah. Some other considerations are artifacts. So the AI and algorithms aren't perfect and can essentially add details or change the image slightly and create visual inconsistencies through that. And then, yeah, for the future of image upscaling, well, it's already extremely powerful and it's evolved over the last few years. And I mean, from this image, you can see how it's evolved with the frames that it's getting. So I believe it'll just continue to get better and better and make gaming more accessible for people who don't have money to continue buying the newest graphics card every couple of years. Yeah, thank you. Any questions?